So today we're going to be talking about trig identities, and to start off, your best friend is going to be your formula booklet. So all of these formulas right here are going to be the basis of this whole thing. So I'm going to walk you through two problems. I'm going to start off with the hardest one, which is proving a trig identity by using all these formulas. And the second one, we need to find theta within a unit circle. So for the first one, it says prove that 2 tangent of x over 1 plus tangent squared of x is equal to sine of 2x. In order for us to do that, we want to deal with the side that's the hardest. So in this case, it would be this one. It has tangent and it has a fraction, while this one is just sine. For this type of problems, you may not know what to do at first since you see all these formulas, so you don't know what you should change. So the most convenient thing to do is change the most complex function that you see. So in this case, it would be tangent squared of x. So we could change that to, we know that tangent of theta is equal to sine of theta over cosine of theta. So if tangent of theta is squared, we know that it is equal to sine squared of theta over cosine squared of theta. So we're going to start off by doing that. Over 1 plus sine squared of x in this case, and cosine squared of x is equal to sine of 2x. So the next thing we could do here would be to start combining things. So in this case, we would need to move all of this to this side in order to combine sine with sine, and then leave this tangent function by itself. So we're gonna multiply this on both sides, and that's gonna leave us with 2 tangent of x equal to sine of 2x times 1 plus sine squared of x over cosine squared of x. So what we would do next is distribute to these two. But before we distribute, just take a look at this. We only have a sine, and then inside the parentheses we have a cosine as well. So then that's not really going to help us to simplify things out. So we're going to use the double angle formulae, which is sine of 2 theta equal to 2 sine of theta times cosine of theta. So we're going to replace sine of 2 theta, 2x, with that. So 2 tangent of x is equal to 2 sine of x times cosine of x, 1 plus sine squared of x over cosine squared of x. And now we're going to distribute, and that would leave us with 2 tangent of x, 2 sine of x times cosine of x plus 2 sine of x cosine of x sine squared of x over cosine squared of x. So you have a bunch of things, then you might get really scared. So just try to. So once you get to a situation like this, you try to simplify things out to make it easier for you. Don't freak out if you started off with less and now you end up with all of this. So we're gonna keep going. We're gonna simplify. So 2 tangent of x, and we're gonna leave it like that for now. Equals 2 sine of x cosine of x plus, and then this is when we could start simplifying things, where we have cosine of x and then cosine squared of x. So we know this cosine of x fits 1 cosine of x into this cosine squared of x. So easier done than said. So 2 sine of x, my bad, times sine squared of x over cosine squared of x. So we already got rid of that thing. I'm sorry, this should be a cosine of x because we already canceled it. So what we should be doing is getting common denominators, and the way we're going to do that is similar to the way we cancel out this right here. So we're going to, write everything down again. And this time, we're going to turn this cosine of x into a cosine squared of x. And then we put the common denominator. Because if we were to do this division right here, we would go back to this right here. So these two are equal, and now it has the same denominator as the thing we're trying to add. So let's do it. Plus 2 sine of x times sine squared of x over cosine of x. So let's put it in parentheses to not get confused, because it's really easy to do that with these type of problems. So then that plus 2 sine of x sine squared of x all over cosine squared of x. Cosine of x. So now we're in a tough situation, and this is where we have to remember not what's in the formula booklet and not what's being taught in the unit, but just basic math. How can you make this more simple for yourself? So we know that we have 2 sine of x, we have 2 sine of x, so then right now we're lost. So why don't we just try factoring out this 2 sine of x and this 2 sine of x out of the entire thing, and let's see what we get. So when we factor it, that goes outside of the parentheses, and cosine squared of x plus sine squared of x. So, oh wait, this is equal to something, and it says so on my formula booklet. Cosine squared of x plus sine squared of x is equal to 1. So that is how we can combine just the basics you get taught in math with this unit in particular. So let's do that. 2 tangent of x is equal to 2 sine of x would be times 1, since this whole thing turned into 1. So let's simply write 2 sine of x over cosine of x. And now we can go back to our trig identity. Tangent of x equals sine of x over cosine of x. And in this case we have a 2 up here, so we're pretty much done. This is equal to this, because 2 tangent of x is also this thing right here, 2 sine of x over cosine of x. So we proved that 2 tangent of x over 1 plus tangent squared of x is equal to sine of 2x by using our formula booklet, factoring out using our basic math, and then we used our formula booklet again. So now let's go to the second problem. We have this equation right here, and what we're trying to do is find theta within negative 360 degrees and positive 360 degrees. So what we're gonna do first is we're trying to isolate theta, or simply get cosine of theta to be something that we can find within the unit circle. So let's start off by dividing by negative 8. So 4 times square root of 3 divided by 8 is equal to cosine of theta. And now we're going to simplify this. So we know that 4 over 8 is 2. 4 over negative 8, it's 1/2. 4 over negative 8 would be negative 1/2. So that's just simply 3 over negative 2 is equal to cosine of theta. And this must sound familiar to you. because it's in the unit circle. And we know that cosine represents our x coordinate, so we're going to be working with, and we know it's negative, so we're only going to be working with the second and third quadrant, so we can kind of forget about this. And we know that we can find -3, 2 at, we're talking about degrees, right? That would be at, so this is 90. We know that cosine represents our x-axis, and we're in the negative side, so that would be at it would be this right here, which is also equal to, let's see, 90, 120, 135, 150. That is also equal to -3/2, and let's not forget that it's also right here at 210 degrees. So 210 degrees equals -√3/2. So then what we're gonna do is, let's not forget this right here, and we're gonna go in the positive direction first. So if we start from 0 and go to here, well, it's obvious we get 150 degrees, and we're gonna call that x1. Our second answer is gonna be 210 degrees. So, yep. And what if we tried to go in the positive direction a little bit more? Well, we pass these two, and then there's no more negatives in the x coordinate. So then this would go past 360. So then if we kept going, this would go past 360, and we know we don't want to do that. So now we're gonna rotate in the negative direction. So from here to here, so we are 30 degrees short from 180. So that would be -150. And if we did it again, we would be 30 degrees over 180. So -210. And then again, if we kept going, then that would go past -360. So we don't have to do that. So those are our 4 answers. Now, one thing to keep in mind is we know that these two are just these two, but in negative. Well, it's not gonna happen in every case. So remember, always do this thing, and don't just put negative for everything if you have a domain like that. So those were our 2 problems. So we proved this identity, and we ended up with this, and we ended up with this right here, and here we found theta and found it in the unit circle using these. So thank you for watching, and I hope you learned something. I'm gonna give you guys some homework so you can practice, and that is gonna be for number 1. It's gonna be a similar problem. You're gonna have this equation right here, 2 sine squared of theta plus 3 sine of theta plus 1 equals 0. And you're gonna find theta for the domain, for this domain right here. So that's, yep. And the answer to this is going to be in the description. And the second problem is going to be to show / prove that 1 minus cosine squared of x, cosine squared of 2x over 2 sine of x cosine of x is equal to sine of 2x. So those are your 2 problems right there. Remember to do them yourself, and then make sure they are correct by looking at the description down below. So thank you for watching, and I hope you learned something.